Hi guys, it's a favorite teacher, Kamajimwasa, and welcome to Skills and Academic Tuition Center. As Skills and Academic Tuition Center, we offer online tuitions and physical tuitions in mathematics, in physics, in chemistry, in biology, and integrated science. So in this video, we are going to look at the more concept, but under the more concept, we are going to look at the relative masses. There are three relative masses that we are going to look at. The first one is the relative atomic mass. Then the second one is the relative molecular mass. And the last one is the relative formula mass. So now, let's start with the relative atomic mass. So the relative atomic mass is the average mass of one atom of an element compared to the mass of 1/12 of one atom of carbon-12. So the masses of the atoms are too small, so they are compared to each other. And carbon serves as the reference point for determining the atomic masses for all the nuclides. So when determining the masses of all the nuclides, the atomic masses are compared to that of 1/12 of carbon-12 isotope. Okay, so let's try to look at another relative mass apart from the relative atomic mass. So we look at another relative mass, which is the relative molecular mass. And the relative molecular mass is the mass, the relative molecular mass is the average mass of one molecule. The average mass of one molecule of a substance compared to the mass of 1/12 of one atom of carbon-12. So the relative molecular mass is basically applicable to molecular compounds. To molecular compounds or the covalent compounds. We look at the other or the third type of the relative mass, which is the relative formula mass. So the relative formula mass is the sum of all relative atomic masses of atoms that make up a compound. The sum of all relative atomic masses of atoms that make up a compound. So here, how do we find the sum of all the relative atomic masses of atoms present in a compound? So that brings us to how we can calculate the relative formula mass or the relative molecular mass. Let's look at this example. So if we have calcium carbonate, and we are told to calculate the relative formula mass. So first of all, we have to identify the relative atomic mass for each atom that is present in the compound on the periodic table. So the first thing that you do is to find the relative atomic mass for each atom present in a compound. So like in this case, we have calcium, we have carbon, and we have oxygen. So we should know the relative atomic masses for all these atoms that are present. Then after that, we have to multiply. We multiply the relative atomic masses, of each atom by the number of that particular type of an atom by the number of the type of an atom present. So like in this case, So like in this case, we have to know how many calciums are here or are in this compound, how many carbons are there, how many oxygens are there. So if we know the number, the actual number of that particular atom, then we multiply that number with the relative atomic mass. Then from there, we add the relative atomic masses. We add the relative atomic masses so that it gives us the relative formula mass for calcium carbonate. So the first thing here is to find the relative atomic mass of each atom present. Then after you find the relative atomic mass of each atom present in a compound, then you multiply the relative atomic mass for each atom present in a compound with the number or the actual number of that particular type of an atom. Then from there, you add all the relative atomic masses in order for you to find the relative formula mass or to find the relative molecular mass. So example, our example here is first one is calcium carbonate. So we write the chemical formula for calcium carbonate down here. Okay, so in calcium carbonate, there is one atom of calcium, one atom of carbon, and 3 atoms of oxygen. So as we are trying to determine the relative formula mass for calcium carbonate, so since we have already identified the atoms present, so we are going to start with oxygen. What is the relative atomic mass for oxygen? So oxygen has the relative atomic mass of 16, then multiplied by the number of atoms of oxygen that are present in calcium carbonate. So in this case, there are 3. So when you multiply 3 times 16, you have 48. Then you go to carbon. So carbon has the relative atomic mass of 12. Then the number of atoms present, 1. Then you have 12 there. You move on to calcium, which has got the relative atomic mass of 40, multiplied by 1 atom present, you have 40 there. Then, when you add everything, so we say 8 plus 2 plus 0, which is a 10, you write a 0 there. Then you have 4, 5, 9 plus the 1, which is 100. So in short, we are saying the relative formula mass for calcium carbonate is 100. The relative formula mass for calcium carbonate is 100. We look at example 2. So example 2, we have aluminium hydroxide. aluminium hydroxide. So we write the chemical formula for aluminium hydroxide. Aluminium hydroxide. So in aluminium hydroxide, there is 1 atom of aluminium, 3 atoms of oxygen, and 3 atoms of hydrogen. So this subscript 3 is for everything that is in the brackets. So we begin by determining for hydrogen, then we go for oxygen, then we have aluminium like that. So the relative atomic mass for hydrogen is 1, then multiplied by the number of atoms, which is 3. Then there we are going to have 3. We are going to have 3. So we write our 3 there. Then we go to oxygen. Relative atomic mass 16 multiplied by 3. We have 48. Then we go to aluminium. Relative atomic mass 27 multiplied by the number of atoms 1. Then we have 27. So when we add this side, we are going to have 18. So we write 8, we carry 1. Then here we are going to have 6 plus 1, which is a 7. So the relative formula mass for aluminium hydroxide is 78. So what you have to bear in mind is that the relative molecular mass and the relative formula mass do not have units. I hope you followed through. Thank you for watching.